Hi guys, right, so today we are doing a maths paper 2 Gauteng question paper. So this is a 2024 prep examination for the trial, right? So we're going to be doing this one, which is the Euclidean, and it's going to be an interesting one. So the first part that we have is question 8, right? Question 8 and 8.1.1. So the question statement reads as follows. It reads, in the diagram, let me use my marker. In the diagram below, the circle passes through points A, B, C, D, and G. AD is a diameter. This is an important point. It's a diameter of the circle. BD and AC intersect at H, and AG, or let me just rather say, and the angle of AGC it equals to 58 degrees. The first question states, determine, giving reasons, the size of the following angles. Angle B2, right? So angle B2, which is this one here, how can I find it? Before even going further, I want to make us all get used to this method of Dr. Cape Town. So we're going to use our marker and say Dr. Cape Town. And after writing Dr. Cape Town, I want us all to note what we have. Do we have a diameter? Yes, because they told us. Do you have a radius? Obviously, if there's a diameter, there has to be a radius, right? But in this case, I don't see a radius because I only see the diameter AD. So we don't have this one. Do we have a cyclic quad? Yes, remember that a cyclic quad is a quad that touches all of the 4 points. That has all of its 4 points touching the circumference, to say it quite correctly. And that cyclic quad is what? It's AGCB, right? So we're going to say AGBC. And I know, yes, I'm not using my markers or coloring pens to showcase it because I want our diagram to be neat, but you can do that also. You can use your marker and say this is the cyclic quad, AGBC. It's gonna make our life easier this way. And since we have this, the diameter, you don't need to showcase it because they told us about it. And do we have parallel lines? No. Do you have a tangent? No. So we only have two theorems that we are going to use. The diameter one, which is the angle at the center, it equals to, no, not angle at the center, but rather angle in a semicircle. I apologize for that. And the cyclic quad, of which we know we are going to apply opposite angles in a cyclic quad, are supplementary. Right, now let's begin. So a cyclic quad is this one, and we do have another one, if I can look correctly, but yeah, that's the first one that I see, the AGCB cyclic quad. So they asked for angle B2, of which angle B2, let's remove this red line because it's not quite clear, but I hope everyone saw it. So our cyclic quad is this one here, and here, and here, and here. So angle B2, they didn't say angle B itself, which is the whole angle itself. They said angle B2. They were very adamant. Okay, so we have our diameter, which is here, and I said for our diameter we're going to use angle in a semicircle, and there it is. So this means that angle B2 is equals to 90 degrees. The reason being angle in a semicircle, right? Okay, now for 8.1.2, it states find angle B1. So for angle B1, how can we find it? Which is going to won't be a problem because we know that we have a cyclic quad AGBC. So our cyclic quad is AGBC. If we use angles in a cyclic quad are supplementary, we are going to get angle B1 because we have angle B2, which is 90 degrees. So we can just cancel them out. Let me show you. So we're going to say angle G plus angle B itself, or let's just say angle B1 because we're looking for B1, right? Angle B1 plus angle B2 is equals to 180 degrees. Y angle in opposite angles in a cyclic quad, opposite angles of cyclic quad. I know my handwriting is so bad. And then we're gonna say angle B1 is equals to 180 degrees minus the 90 minus the 58 degrees, and angle B1 we should be 32 degrees. Okay, then from there on we go to the last one, which is 8.1.3, and which states find angle A2. Okay, so angle A2, we know that we have angle B1, which is here. We can say rather angle A2 is equals to angle B1. Why? Angles in the same sec. So I'm gonna say angle A2 is equals to angle B1. This is B1, by the way, of which is equals to 32 degrees. Reason, angles in the same sec.